In combination circuits, we have two types of combination. First is series combination. First is series combination. So, in series combination, the resistance are connected one after the other. So, if this is my first point of one resistance, one point of one resistance, then the second resistance is connected to the second point of the resistance. In this way, the resistance are connected. Now, if I take a battery of some voltage V, if I take a battery of some volts V and my current I is flowing through this circuit, then that current has to flow from each and every resistance. So current has to flow from each and every element of your circuit. So this is your series connection, and the second is your parallel connection. Second is your parallel connection. In parallel connection, between two points A and B, there are resistances like here also. Okay, but the start point and the end point of this resistance is common. The start point and the end point of all this resistance is how it is common. It is starting from one point and it is ending at one point. Okay, so just let us see in a proper manner in a bigger diagram for your better understanding. So parallel connection. In parallel connection, what it is? In between two points, A and B, the resistances are connected such a way that their start point and end point is common. So this is my resistance 1, my resistor 1, this is my resistor 2, this is my resistor 3. So in this way I have connected here 3 resistors for now. So in between 2 points, this is point A and point B, my 3 resistors are connected. Okay, how? The start point and the end point is common. So if I provide a battery again to this circuit, my current I will flow, right? And after coming here, that is after coming at point A, what happens? There are 3 paths for him. So he has to go through all the 3 paths. It is not like this, he will go from one path and the other 2 will be like that only. It has to flow from all the 3 paths, right? So it will get divided into 3. I1, I2 and I3. Then it will flow from R1, R2 and R3. And after coming here at point B, it will again get added up and it will come to the circuit. So, in series, there were resistance one after the another. End point of one resistance was connected to the start point of the second resistance. And in parallel, between 2 points, that is one start point and one end point, we can say, the resistance are connected. So now we will try. Now this is, there are a lot of resistance, so we can replace this or we can find out some equivalent resistance for this. So now we will find out the equivalent resistance for series connection and then for the parallel connection. So let's find out equivalent resistance first for series connection. For series connection, first we will find out equivalent resistance. So just now, as I have told you, just take one resistance, name it as R1. We are going to connect 3 resistance. So endpoint of this resistance is connected to the second resistance, that is R2, and endpoint of R2 is connected to third resistance. So that is your R3. Now we want to study this. So what I have to do? I will apply a potential difference. I will apply one battery to it. So this is my battery. This is my battery with a voltage V. Now I have already told you what the current in the circuit is same. This same current will flow from I current will flow from R1, I current will flow from R2, and my I current is going to flow from R3 as well. So my current will flow through each and every element. So my current I is same in series connection. My current I is same in series connection. But what about voltage? What about voltage? So when my current I will flow through R1, there is going to be a potential difference in across R1, that is going to be V1. Potential difference across R1 is going to be V1. Potential difference across R2 is going to be V2. In the same manner, potential difference across R3 is going to be V3. Now, what you are studying equivalent resistance. What does this equivalent resistance means? So here there are 1, 2 and 3 resistance. There are 3 obstacles to your flow of your river. So instead of this 3 obstacle, I can just skip one single obstacle, right? And that single obstacle should have equal value to this 3, right? This 3 should be, if I am combining this 3, then that 1 should do the same work as this 3 are doing. So what I am trying to do? I am trying to replace these 3 resistance with a single resistance, and that single resistance is nothing but my RS. RS, that is equivalent resistance. So my voltage is going to be V only, my current is going to be I, but these 3 resistance are replaced with a single resistance RS. But what is the value? What should be the value of this resistance? How we can find out this value? So let's try to find out the value of RS. So what we will do? Now here voltage V is been provided. Okay, voltage V is been provided to the circuit, and this V is going to be equal to the potential drop across the 3 resistance. It is going to be equal to potential drop across all the 3 resistance, addition of potential drop across all the 3 resistance, that is V equals to V1 plus V2 plus V3. It is going to be V1 plus V2 plus V3. Okay. So what is V1? That is potential drop across R1. V2 is potential drop across R2. And V3 is potential drop across R3. How you can find out this? We have studied Ohm's law. What Ohm's law says? Your voltage is equals to your current and resistance. Voltage is proportional to the current flowing through it. So now for resistances R1, what it is going to be? For R1 resistance, what is my voltage here? For R1, what is my voltage? V1. Current, same, it is going to flow through all the resistance. What is the current from all the resistance? That is I. So current is going to be I and R1, right? Similarly for R2, what it is going to be? V2 which is equals to I R2. For R3 it is what it is going to be, V3 is equals to I R3. Okay, now about the total potential. So I have told you that we are going to combine this, we are going to reduce this three resistance in such a way that we have to use only one resistance. So what we are getting, RS, V and I. So our total, now what is that resistance? RS. So for RS, our voltage is what? The voltage which we have provided, V is equals to IR, right? V equals to IR. Okay, so for resistance R1 we have V1 which is equals to IR1. For resistance R2 we have V2 which is equals to IR2. For R3 we have V3 equals to IR3. And when you combine these three resistance, you are going to find out an equivalent resistance, that is RS. So for that RS, what you are going to have? V equals to IRS. Okay. So now we'll keep it in this equation. We'll keep it in this equation. So what you will get? Instead of V, what you are going to keep? IRS. Then instead of V1, what you are going to keep? IR1. What you are going to keep? IR1 plus IR2 plus IR3. Right? This is what you got. I will rub this part so that it will be easier for you to see. Even I will rub this circuit. Okay, and I will rewrite this equation. So it is going to be easier for you. But I hope you have noted it down. I hope you have noted the voltage drop across R1, R2 and R3. Okay. So what was it? IRS is equals to IR1 plus IR2 plus IR3. So from here you can see your I is common. So you can constant. So you can take it out common. So I equals to R1 plus R2 plus R3. And this was equals to what? IRS. So I and I. Cancel it out. What you are left with? RS equals to R1 plus R2 plus R3. So this is the value of your, this is the way how you can find out the value of your equivalent resistance. So when you combine the three resistance, that is when you do summation of three resistance, you will get a equivalent resistance. So in series connection, how you get the equivalent resistance? You get the equivalent resistance by summation of all the resistance. Now instead here I have three resistance. Maybe I can have 4 resistance, 5 resistance, 6 resistance. I don't know how many resistance I can have. So what it will be? R1 plus R2 plus R3 plus so on many resistance Rn. So N stands for any number, the number of resistance you have in your circuit. Okay, so this is the way how you can find out the equivalent resistance, that is Rs. So Rs equals to R1 plus R2 plus R3 plus so on up to the number of resistance you have. This way you can find out the equivalent resistance, right? Now just see, it is what? Summation of resistance, right? It is summation of resistance. So your equivalent resistance will always have value greater to your highest resistance. It will always have a greater value to your highest resistance. Okay? So what you do in series connection? You add all the three resistances. Okay? So this was about your series connection.